Today we're diving deep into a really important document. This is a technical explainer for the Pantheon project's deliverable D3.7, titled, Overall Architecture and High-Level Functionalities. The question this whole project is trying to answer is, how do you even begin to build a digital shield for an entire city? We're talking about a system that can see a disaster coming, model what might happen, and help people manage the chaos. It's a huge challenge, and this document is where the solution begins. Here is our agenda. We'll kick things off with the Pantheon project's overall mission. Then we'll zoom in on this specific document, deliverable D3.7. From there, we'll unpack the architectural blueprint and see what the core components are. And finally, we will examine the path from this conceptual plan to a real-world, operational system. We begin with the mission. What is the primary objective of the Pantheon project? In essence, it is focused on building a community-based digital twin. The central concept is to make our cities significantly more resilient when a disaster strikes. Pantheon is a major project, supported by the European Union's Horizon Europe program. The main goal is to create something called a Smart City Digital Twin, or SCDT for short. It can be conceptualized as a living, dynamic virtual copy of a city. It's designed for one specific purpose: to give authorities and first responders the tools they need to manage a crisis more effectively. Given this ambitious mission, how is it actually implemented? This is the function of deliverable D3.7. It is not merely a report. It is the master plan, the blueprint for the entire Pantheon platform. What's inside? It all starts with the architectural blueprint. It shows us the system from two totally different but equally important points of view. The first way to look at it is what they call the layered view. And the best way to get this is to think of it like building a house from the ground up. Right at the bottom, the foundation, you have layer 1, data and persistence. That's where every piece of information is stored. On top of that, you build layer 2, the models layer. This is where simulations and machine learning models live. Then comes layer 3, the back-end services. That's like the core logic that makes it all work. Layer 4 is the analysis and optimization engine. This is where you can run what-if scenarios. And finally, at the very top, you have layer 5, the front end. That's the part you can actually see and touch, the user interface that the decision makers will use. So, what's the point of this layered view? Simple. It tells us what the platform is made of. It breaks a very complex system down into these manageable levels. It makes the whole thing possible to design, build, and, importantly, to manage. That's the first perspective. The second one is the functional view, and this is really important. If the layered view shows us what the system is, the functional view shows us how it all works together. It's the map that shows how all those pieces, across all those layers, actually communicate with each other. It's all about the flow of data and how everything depends on everything else. Okay, let's zoom in a bit further. We've seen the high-level architecture. Now let's look at the actual building blocks, the core components that make it all function. First, this system is a data-intensive. It has to be. It ingests a vast amount of information using components called data connectors and aggregators. We are referring to satellite images, street-level data, weather information from IoT sensors, real-time feeds from drones, traffic data, and even data coming directly from the community. Once all that data is flowing in, it is sent to the brains of the operation, the analysis and decision components. This is where the magic happens. The data is processed by machine learning models and simulation models. They generate insights, support decisions, and run those what-if scenarios. All of that is then served up through the user interface. Behind the scenes, there's a component called a message broker. You can think of it as a central traffic coordinator, making sure all the different parts can communicate with each other without causing a bottleneck. The criticality of this is emphasized by a quote from the executive summary of the document. These components set the groundwork for the technical development of the Pantheon platform in Work Package 4, 5, 6, and 7. In other words, this design document isn't just a suggestion, it's the absolute foundation for all the coding and building that comes next. This brings us to the final piece of the puzzle. How does all of this detailed blueprint, actually become a real, usable tool? The document itself lays out the roadmap. Currently, we are in the design phase, which is what this report details. The very next step is integration, where developers will begin to connect all these components. After that comes deployment, which involves installing and running the platform. And then the final, crucial step, verification. This is where the system will be rigorously tested to ensure it can handle the immense pressure of real-world disaster management. This brings us full circle. The Pantheon project, with the incredibly detailed planning seen in D3.7, is attempting to build something that could be a true game changer. So, I will leave you with this question to consider. Now that we have a blueprint this detailed and comprehensive, can technology like this actually help us, as communities, prepare for the things we cannot predict?